Hey, good morning. Let's continue. So yesterday we were able to make this crash. We were able to see that it would crash at a certain point, but we didn't have enough detail to know exactly when it would crash. So now I feel like I'm not seeing this information here. We've trace set up. Maybe it's because the telemetry isn't making it to the log, so the traces aren't being logged. Ah, okay. Let's add some more logging. Now we can see that this hits. Mm. So we have a broken pipe. Go back before that. Looking for data plane on the left. Send mutation error. The DB mutation listener crashed. Data plane. Received a DB mutation. Received a DB mutation. Where is this? Ah, okay. So we have an event. Let's just use events then. Received that. And then it crashes from here to there. Hmm. All right. Oh, that self.pos? Hmm. Ah, but that is already done. Let's say read frame. Okay. On commit record. Let's try again. All right. Zoom in. Hammer on it. All right. Broken pipe. Data plane. We see that it's crashed. Seeking. So we're trying to get to this location. We've received a DB mutation. We need to go to this start position. I want things to look a little better in the logs. So DB mutation. Okay. Now we received a seek, but we never found a commit. So something crashed within this. Huh. So let's just say if something did bubble up, why are we not seeing it? If something did cause an error, we see this. Lots of good errors there, but wait, that's not the error we're seeing, is it? It was broken pipe for the app. DB mutation listener 54, send mutation error. Come on. So the listener can't send because the receiver hung up. But the mutation RX is that loop we were looking at here. Mutation receiver. So why are we not seeing this error? So there must be something wrong with reporting these errors. So we have this join set. I don't remember seeing that. What if we just returned with an error? What do we have there? Whatever. Something easy to set up. FIFO error. Or inspect error. Let's try that. Give that a run, because it really just looks like we're not getting the error. Welcome pipe. Send mutation error. Oh no, there was an error. Wall log seek error. Bum bum bum. Oh. Hey Sam. Happy Monday. How are you? Coding in Python. What's your go-to editor for Python? Why didn't this crash it? NeoVim? I like NeoVim. I just don't like configuring NeoVim. All right, so what happened here? Weren't expected. There was an error while log seeker, and this would have been after receiving quite a few seeks. Right. So it must have rotated. Lazy Vim. Ah, nice. Okay, so why would we have received a seek position? And what is this wall log seek error tell us? Why? It says currently we're at, maybe this is a position? Current what? Expected what? So I get our wall log and we see here if the current position is greater than the expected position, so why would we ever try to seek to the past, to something before where we currently are? Seems like we're not handling some case here. Or that maybe some of the mutation stuff we fixed yesterday actually broke something else. Hmm. What I kind of want, I want a log to file. So I don't really want to just scroll through here, filtering the bits that I'm interested in. Guess I could reduce the other pieces. See, here we found a commit record. Now remember, this is all single database. There's not multiple databases. Waiting for mutation. Received a DB mutation. Start position is there. Length is that. Reading from frame. Found a commit record. Waiting for mutation message. Let's see, this is 133, 961. Well, salt changed here. Wait, that's the previous salt. This is 132. And the previous one was 133. It did this rotate? Did this wall log rotate? I don't see. Uh, let's scream loudly when a wall log rotates. It's in a file. Notify commit end. Here, rotate wall. Warn, renaming blah to blah. Okay, we did not see that. Why didn't we see that? The salt's changed. Okay, let's double check this. broken pipe. Okay, snafu. Specifically looking for the rotation. So salt 1 is a random number, and then it increments whenever the wall log rotates. Salt 2 is always just a random number that is specific to that wall log. The combination of the two is sufficient enough for an ID for a file. So here we have 132. Here we have 133. So why would it have gone down? What was the previous one? 133. What? This is bizarre. So it looks like we have, wall log 133 just doing its thing. We wait for mutation messages. It looks like it was 133 for a while. It's working. 133, 133. Scrolling back down. Consistently reading the data out of the wall log, right? It has not rotated. Still that. 133. And then things change. And file salt is 132. What? This is the data we received. 132. So the VFS sends 132. And this, of course, should be different. Let's see, 7507. Yeah, salt 2 is just completely random. Completely different. Okay, so the VFS sends different salt for whatever reason. What happened between these? It might actually, let's see, let's start up here. Here we received a message, then all the blue between the two. Wall sync. Okay, main DB. So we sync to file, sync to disk. Main DB. We don't really care about main DB stuff. Here, wall. We read file 470 0. It was a success. 470 0. We write 24 bytes at offset 181 312. It's a success. Then 4K following that, and the info's different. Huh. Okay, so we subtracted an ID instead of adding an ID. The offset is very high, right? This isn't a rotation at all. Main DB. Does anybody else actually send? Maybe there's just some other logic bug. So file, rotate wall is not being called. Calling notify Notify commit end is being called. It's only called by wall write page. So we write the page. We were seeing that. And if success, and we can take the commit end. We notify commit end. And where do we get the salt? Self.salt. Expect to be salted. So are we changing the salt at all? No, it's salt 0, salt 1. So who would have changed the salt before then? Fascinating. Set salt. Commit start. Commit. Let's log the salt change. We're not going to describe those in there. We just know what they are. Current position. Hold on. One more time. This is a strange bug. Glad we're dealing with it now, though. Okay, so we should see some big orange blobs whenever we change the seasoning. I'm not seeing it at all. There is no big orange blob. This is a commit page. So the salt doesn't change. 4639. Okay. 4638. It decreased by 1. Ah, the mystery deepens. Okay, so if it's not on the VFS side, which is what we currently checked, the VFS did not attempt to change the salt. Which means it's over here. So that we must have some logic bug for file salt1 on this. But we received a DB mutation. The DB mutation is, we don't change that. At least I don't think we do. Where we're logging this, received a DB mutation. That's like right out of the pipe. Here. We did not change it in that time. DB mutation receiver. Okay. Let's go to the FIFO bit. We read it off the FIFO. Map some errors. And send it. Super simple. Oh. It really seems like the pipe changed it. Wait, I want to check one more place. So here, is there anything else that modifies file salt? We create a new wall state. Hmm. Okay. Set the salt. Yep, got that. That's just getting a copy, taking the salt. That changes it, but not in the way that we're thinking. And this is just the definition there. I guess the other one that we didn't inspect was this, but the file salt would have been none. So set salt should have been called if it's the culprit. 46, 39, 46, 38. Wow. File salt. Here we call set salt. Just run should compile it. Yeah. All right. Given the current status, I'm just not believing that's killing it. Wait. File is not a database. SQLite error. What? Hmm, I think I didn't let it start up. Okay. There we go. A log. File is not a database. That's new. It seems as though we've corrupted something. I'm not surprised. Actually, I am surprised. I'm not sure how we would have corrupted it, but that's not the bug we're chasing. One appdb. Everything. Yes. All right. Brand new file. SkyO error. Really? Broken pipe. This is strange. Oh, no, no, no. See you later. 778. Disk IO error. Huh. Anyhow. Current position. All right. File solid 60, 65. 60, 66. All right. So it did go down. we see that has gone down. And also, I did not see any orange text saying that we were setting the salt, changing the seasoning, anything like that. Nothing. So, DB mutation. We have this really thin little crate that calculates like the path of a new wall log. It reads from the FIFO, it writes to the FIFO. So we're just going to ePrintline in here. It's kind of like it's between two things, and the VFS and data plane. Now both of those have different kinds of logging. Right? The VFS is using FlexiLogger, and data plane is using tracing. So in here we will introduce a third ePrint line. Writing FIFO. Start, pause, length, file salt, and oh, that's file salt 1, file salt 2. Do the same thing on the read side. Read from FIFO, start, length, and the file salts. Oops, wrong one. Here, just run that. It's off by 1 error. Oh, off by 1. How we love thee. Let us count the ways. 1. Writing to FIFO. Okay, so here we get some reads and writes to FIFO. Okay. 1093, 1093. 93, good. Read from, wait, where's the write? We got a read from FIFO. Oh, it must have been backed up. 1093, 1093, 1093. And by this point, it's crashed. Let's go back a little further. 1094, okay. Back, writing to FIFO, 1094. 1094. Writing, 1093. Ooh. How did it change? Okay, so it's on the VFS side. Let's comment out this. So we know it's on the VFS side because it's writing, and the only place this is called is from notify commit end. Okay, salt 0 changed. We get that here. Salt. It's unchanged here. We just cloned that. That's a copy, isn't it? At one point, there was more information in there. There was a vector, something like that. It's not there anymore. So if we get it from the salt, let's go over this again. File salt. Here we're replacing. Seasoning is changing, like log warn. We didn't see that. That doesn't change it. Taking it doesn't change it. I am so confused. Unless there's a separate one, but we still would have seen set salt being called on it. Setting the salt seems to be the only way. Here, let's just to make it maybe a little bit more visible. Spec log area. Okay. Unless the compilation isn't building the VFS for some reason, or it's not loading the VFS from the right location. Okay, it's up and running. Hammer on it, cause it to crash. Look for error messages. No. No. Not seeing error messages at all. And if we go to the beginning, how far do we have to go before we see that? I just want to see it called. Wow, this went on for a while. Oh, probably because this is happening at wall rotation time, and that doesn't happen very often. Strange. So we're at the bottom of the log again. Why do we get this? Wait. No. This is from the VFS. We're writing to standard out. Okay. Yeah, that's log warn. And here. Right, we were logging right here, and we saw that it changed right there. Self to FIFO, that does not change it. Starts off as none. Is set only in one place. Is there something keeping this? Log error. Ah, there. And we saw the ePrint line work, but we're not seeing. Yeah, let's hammer it. We're not seeing that message here. Gaidoro, how are you? Raid and run and welcome, Christoph and Raiders. Happy Monday, man. Well, everyone, we are in search of an off by one error. Always conflict, no matter what era. Okay, so let's bring you guys along the journey with us. Let me pull up some diagrams to help with the explanation. Just a moment. Let me make sure dark mode is on. Dark mode is now on. Good. Yet another chill stream after the fiery stance of Christoph and Toggle. Well, thank you. Yeah, okay. Now it's going to be. Now I've done my best. The actual editing area of this application still has a lot of white in it. So, but I turned dark mode on, so all of the chrome is darker. So here we go. Watch your eyes. If you're lying there in bed late at night, and I've warned you. Okay. Oh, that and here, they're a little darker. Okay, but this is our application. Now, here, so okay, the goals here, quite obvious. We're building a website for my wife. All right. Now, it needs to be scalable. Oops, looks like I missed a little asterisk there. We wanted to favor read-heavy websites, right? The technology. It needs to not die if we build something write-heavy with it. It needs to be fast globally, right? We don't want people in Australia having a subpar experience. Easy to build on and point-in-time recovery, DB recovery. Okay, because I think that's the kind of tech I want to build my wife a website. Think like forum and wiki and anything that you would need to build a community. Okay. Now, maybe even chat, right? Messaging. Anyhow. So we have a load balancer that's coming in from wherever, right? If we're on AWS, that's one of their load balancers. If it's on Fly.io, it's one of theirs. We have our proxy. The proxy differentiates between read and write requests. Now, inside of this, we have an application. Right? That could be a forum. It could be a blog. It could be whatever. Okay. That will use SQLite. I know. That awesome database technology that runs on a toaster. We will have our very custom virtual file system plugin. Written in Rust. It monitors for changes to the database. The VFS will notify this application sitting on the same machine that a mutation has happened. Data plane will fetch the change from disk and send it on to data archive, which will then replicate the changes to the other machines, the readers. Okay, there's a lot there. Questions? I'll pause for questions. Yes, absolutely. This will make it so that the website can run on a toaster as well. Probably a fancy toaster, not one of those 1950 toasters without, without chipsets in them. But okay. Now, the current issue we are chasing down is that there is a change happening somewhere between the VFS and the data plane. It appears as though the VFS, I should take a step back, just one little step back, and explain a little bit more of the technology before I get into this. Okay. So, SQLite, we are forcing every database to use wall mode, right? That's write-ahead logging. And that produces some files. We'll get to that question in a moment, Blurry Cat. Great question. Okay, so those wall logs, there is an identifier at the top of the wall log called a salt. And for any given database, let's call it database happy, they would have a salt. And the salt is two pieces, salt 1 and salt 2. Salt 1, for the wall log, increments whenever the wall log is reused. Now, what we're seeing is a decrement in the salt whenever, well, for some reason, we're actually seeing a decrement. Okay? And that's what we're chasing down. There should not be a decrement in the wall log. All right. Let me catch up on chat here. How did I even go from I want to build a website to let's build a custom SQLite VFS? Great question. And that's a pretty simple answer. Fly.io has this cool technology that, I don't know, they hired in. It's, what is it? Fly.io. It's LiteFS. So I wanted to use their LiteFS technology, which is very, very similar to what we're building. However, when I started using it, and it's very similar to what we were discussing already, but it's built on top of Fuse file system, and that's how they are detecting changes. I have 100 tabs open. You can identify with, well, thank you. But because of Fuse, it limits the write throughput to about 100 transactions per second. Well, that's not high performance. That's actually pretty low performance. So that would be 100 transactions for all databases on a machine. And if you were running a forum that's somewhat busy, 100 isn't going to cut it. So I needed something that was not based on Fuse, but did roughly the same thing. And going back to the diagram, watch your eyes. More power, yes. And that Arnold Schwarzenegger accent, more power. So we needed more. We needed a lot more. And the way to get more power out of a machine is actually to do less. So one of the things that LiteFS does is it writes twice. Whenever an application writes to a SQLite database, it basically sees, it's actually in a different order, right? So their monitoring with the Fuse bits are in the file system layer, which, okay, it's kind of the same place, right? But imagine this is just file system monitoring. But they end up writing what they call a transaction file that their system then distributes. I could do audiobooks, very engaging. Well, thank you. LiteFS isn't a VFS. It is not. It is not a VFS. They've basically implemented a file system that monitors for changes, which also means that they support, actually, right now they support all of the journaling modes. So rollback journaling, whatnot. I'm only supporting wall log journaling, mainly because it fits the need so well. With wall log journaling, you need some sort of mutation on disk, and you need a way to be able to preserve it. Rather, not for wall log journaling, but for replication. So you need to have some data persisted. So if I did rollback journaling, I would have to basically build a wall log out of that data. So why not just start with wall log and then later add rollback journaling, which is the approach I've taken. And thus far, I think we're in the thousands of transactions per second on my M1 Max. Yeah. Well, the good news is you don't have to know about a file system in this case, but Fuse is basically a user space plugin to be able to simulate a file system. All right. Now, okay, I think we've pretty much caught up, and thank you for all the compliments. I appreciate that. So, we are looking for this very elusive decrement. Okay, we're going to be looking at a couple pieces of code and some log files. And I know log files and code might not be the most engaging content ever. However, I have no however. That's all we got. So, here's the code. This library here, it sits between the VFS and data plane. Yeah, the kids are going to be asking me later, what does he mean by that, Daddy? Um, this library here, both systems use it. It's so that I can have consistency between the wall log, between the VFS and the data plane. The VFS writes, data plane reads. Okay. And we saw that the file salt actually decremented by the time it reached this call. Usually we flush the log files, yes. All right. Yeah. So the only place that this is called from the VFS is here, where we're being notified that the transaction has finished. Okay. When the transaction is finished, we tell the other system. The problem is this value, the salt, this is salt 1. Don't think that salt 1 is actually salt 1. Salt 1 is 2 and salt 0 is 1. Okay. Yeah. Now, so we have a salt. Okay, it's two parts, the first part and the second part. And the first part normally increments when the wall log rotates. And we're seeing a decrement. Okay, let me show you what I mean by that. We'll zoom into that. We'll start the system again. And really, this is a very simple system. This is the application we're actually using at the moment. It's called our notes application. And we can give it a note, add a note, boom, it's there. Right? That is our application on the machines here. Okay. It's our little notes app. Now, we do that, we get notes, blah, blah, blah. Okay. However, if we come here and we use the WRK tool to post, hello world to our DB, it's going to hammer it until it breaks. Okay. It happens so fast. Thousands of changes happen and boom, it's done. Oh, disk space is so cheap nowadays. Whoever wants to delete a note, just tombstone it. That way you can feed it to AIs later, right? Have AIs build your notes as they watch you wander around. I need to pour some more tea. Okay. So while I'm pouring tea, let's see if I can do that and scroll up at the same time. So we get some error, right? That error happens, but it's because of some other error. Same with this one. The system is crashing, just as I intended it to. You'd have computers burning with that speed way back then. Absolutely. Sell your data. Absolutely not. No. I would, okay. I wouldn't sell your data. I would ask you to pay so that your data is not sold. Like, that's basically the choice with Facebook, right? For Facebook to make the same amount of money, if everybody paid them like $10 a month, their business model could be like so different. Your data could be protected, and you wouldn't have ads all over Facebook. Or not $10 a month. It was 10 a year, I think, given the number of users and how much they make. I think it was 10 a year. Anyhow, that's something else. So, soon I'll implement personalized ads in the Notes app. Shh. No, no, I won't. Okay, so here we have salt 1. Notice it's 4641 here. Salt 2's random. So whenever the wall log rotates, it's random. Salt 1, 4641. Okay, let's go back in time. Oh my goodness, it's 4642. It actually went down from this point to the next point. But why? Why did it go down? It should never go down. That's how you know I'm not going to go into that business model because, yeah, I'm not going to sell my wife's data. Okay, so it went down, but why did it go down? That's what we're chasing here. So let's minimize that. Here is where we do the DB mutation right. We had this uncommented. We saw the exact same thing, so we know it's on the VFS side. Now the salt is here. Right, maybe there's some oddity in how it's getting passed in. Maybe it's type is changing between one and the other. They're both U32s. Good morning, Mars. Crimson Mana, thank you for the follow. Real the bits, thank you. Proper Bug, Bunny Slayer 2K, and Blurry Cat, thank you for the follows. Okay, so the salt we get from right here. We've also tried looking at everywhere it's being set, and this log error we're not seeing in the logs. That should be a big red line, and I didn't see that at all. So if we scroll up, that's an error. It's a broken pipe error. No red, no red. And we can go up for pages past where the error actually happens. Wait. It's right here. 4642. I didn't see this before. Ooh, the mystery. So the wall log rotated. We can see that there's a write happening at offset 0. That's the header sized. Huh. Did it go down or did it wrap around? Questions, questions, yes. The mystery is afoot. Okay. So at this point, 4642, it changed to 4642. What was it before? Right. Let's add that. Self dot, let's say, is current one equals self dot file salt dot zero. Does that work? Oh, let's just say current. And I think we have to put like a percent or a question mark here somewhere. Is it at the end? Values not, no, I want colon question mark. I don't actually care this much. Let's do, here we go. Okay. If it was some log line I was going to keep around longer, there is a way to annotate it so that you get the data as structured data. All right. So we start it, we hammer on it with WRK, it dies. And then we scroll up until we find the error. I was surprised how far away that was from the actual issue. See, like this just keeps going and going and going. No wonder I missed it before. We must have gotten lucky this last time. Or it's not related, and it just happened to rotate. I think that's more likely the case. Okay, let's remove some of this other chatter. I kind of want the chatter though. I'm not seeing any red lines. All right, going back to the bottom. I didn't see it. Oh, okay. I would have expected it to be much closer. Time for a grep. Yeah, I'm using Overmind. And let's see. I don't, oops. Let's give it one of these. Oops. Oh, interesting. That's not what I wanted at all. Why is it doing that? Hmm. Not going to get anything out of Overmind like that. Okay. So I've got about 20 minutes to find this. So we're not seeing this. We are seeing a change here. Did I show that to you? Can I pipe out to a file with Overmind? Let's check. This one. Proc file. Usage. Not sure. Okay. Anyhow, um, I think we can still. Here, let me show you again. So if we do just run, oh, yeah, let's remove that. Just run. There we go. That's running. We hammer it. It dies. No. In this case, 4140. Hit apply. Okay, we're seeking 4140. Waiting for mutation. And it interrupted. Okay. Every now and then. See, I think we're actually subtly corrupting the database because of this. Okay. Cleanse the database. Run again. Good. Hammer. Broken pipe. Good. Okay. So now, in this case, 2365, 2366. It went down and 2366. It's commit page. We're writing to a file at offset. Yeah, that's a high offset. That's not the beginning of a file. That would not have changed it. Looking for changes to the wall. Wall sync is synced to disk. Red from some position high. Returning 0. It succeeded. We're writing 24 bytes at this offset. That's a wall frame header. Then here's a page write. Those are very high up. There's no reason for the data to change. Overmind echo. Huh. Okay. We'll try that here in a minute. 2365. There was an error. This start position is at basically 120K. What was the last start position? 115K. Okay, and before that, 111K. Right, so we're going up by about 4 kilobytes each time. That should not change the index. It's strange that this. Hmm. I suspect that the wall log is rotating, but I'm not seeing it actually rotate. We should see a wall right at offset 0. I'm not seeing a truncation happen. All right. Unless it can rotate midstream? That would be weird though. And why would the number go down? Okay, let's focus on the number 2365. Why would that change? That is changing, but why? It's almost as if that's for the previous file. Oh, the music is so appropriate. Wind Up Boy, Okira, and Itharak. Thank you for the follows. Okay. So what if it didn't change, but it's the file from before? Are we keeping that around somehow? We have two different selves because we're not seeing the salt change. So it must be from a previous version. Fascinating. How can we identify self? How does anybody identify self? What do we have in self to identify? File name pointer? That might not actually change, but the pointer to that would. Let's print that out. Now let's do a log warn. Let's see. Salt. I want to change this to salt 1, salt 2. There we go. Salt 1, salt 2. Notifying change. Self dot, was it underlying file? Can I borrow it? Let's just move it up one. Okay, let's also have Commit start and length. Done. So now we should get the pointer here. Pointer address. Let's see if we have two different files that we're dealing with. Okay. Commit page. It has crashed. Good. All right. So in this case, oh, I just didn't see it at the end. Okay. Notifying change. It's 3, 4. Okay. So in this case, assault is 8411, and the previous one, 8411, and before that, 8411. 8412. So 8412 ends with, let's see, 147.005C48. Ah, the pointer is different. Okay. So the previous file is actually being operated on. Why? But it has a different salt, so why is it an issue? I should have seen it. It's going to be here. So 5980 here. On the before this one, 5C20. Yeah, I didn't see that. Okay, so we have two different objects that happen to be basically one after the next. Essentially, this one here was created after the one below, and I was expecting this one to be completely retired by this point. I have to think about that. Why would that happen? And why are there more commits to it? So here, commit start 49,472. Yeah. Basically, they're both working on the same file, but one of them has an older salt, which is causing the issue. That is curious. Huh. Why would sqlite do that? Is that a SQLite thing, or did I do that? Notify commit end. We roll the file. How do we roll the file? Here's season. Here's rotate wall. DB mutation, rotated wall path. So we rename one to the other. So we close the previous file. No, no, this isn't it. That's not where it would happen. This is when SQLite's shutting down. It's not that one. This one? No. This one here. So our VFS is supposed to be this layer of indirection between the default file system and SQLite, right? The default VFS, which could be like a Unix VFS, it could be like a Windows VFS, or some custom VFS when you're running on a toaster. Serotonin, thank you for the follow. Stay Peaceful 89, thank you. Unsafe, okay. So what do we do here? We made a change here recently. Storing your data in toast crumbs at the bottom of the toaster. Yes. Okay. What's happening here? Okay. Sorry, I got a little distracted. We have a file header. Write the file header. We parse the file header. And this is only if we're writing to the beginning of a file, right? So a wall log rotated, and this is what I presume is happening. A wall log rotated, and we didn't correctly get rid of the underlying bits. Or SQLite reopened the file when it rotated the wall log. And we do have some data for this. So we could grep for that. So we try to close the underlying file and then rotate the wall, right, rename it, then open a new file. When we open the file, right, we're just calling the default VFS open APIs, file name pointer, underlying file, file flags, out flags. We don't do anything without flags. What if that fails? Okay. Love note to future self. Now VFS does write to logs, so we could grep those logs real quick. Let's prep for that. Let's see, rm dev /1/logs. Yeah, 111. No, let's just remove all of them. Let's run it. Just run. We should see this. I would expect it to be right around that. Okay. It crashed. Good. Rotated once. And the current log. Seasoning is changing. Look at that. Okay. So we see that the seasoning is changing. Salt is 8833. The file. What's going on here? File. It's writing the file header to disk. We see that it's changing. 88. Let's search back. So before, let's see. Yep, that's higher in the file. 8832, 8833. Okay, the file pointer is 54B0. Okay, file pointer for SQLite stayed the same. Right, this is basically a pointer to us. $54B0. That's all the same. We changed the underlying file, so that's expected then. So the previous wall log gets renamed to include the salt1 and salt2. You can see that it's the previous number. I wonder if the file number going backwards was a bit of a red herring. I doubt it. But it's possible. Because Kulisaku, thank you for the follow. So here, this little line there, it's basically a 4 kilobyte buffer. So I imagine that as we are just hammering the website, that's there could be a bit of data in that. Why would it have the new numbers and then the old number? That's what's perplexing me. So this here, is there any? Yeah, 2,000 lines later. See, look at that. Okay, so here we are. We do a rotation on line 484, and then the salt appears again. This is our new log line. Does it appear again? It does. Okay, so it happens a couple of times. Why would it go backwards? Only salt 1 changed. Sorry, salt 2 does change. Salt 1 also changes, but it's off by 1. So when the wall log rotates, the salt 1 increases by 1. Okay. So what is this? What? Only sold 2 change. No. All right. Unfortunately, I have to go do the day job thing. Well, I guess it's not unfortunate. I do enjoy having a day job. So, next time on over engineering a website for my wife, we will continue the chase. This is perplexing. It really is. Sorry, I have to run, but I lost track of time. You can see it. I mean, it's so engaging. 1,000 lines later, right? Salt 1 is the new value over and over and over again. And then, then eventually, 2867, boom, it's back. Why? Yeah, something. I'm not sure. Maybe it did roll back. Oh, that would be fascinating, wouldn't it? That's an interesting thought. What if it started to detect corruption? Hmm. Anyhow, I have to run. We are going to raid. Adam, raid incoming. Thank you all for hanging out. So, till next time. Bye bye. Ooh, an echo.